Here are the steps for preparing the OcuScience Ex Vivo sample holder. This image displays the fully assembled sample holder. It has an upper and lower portion connected with thumb screws, which can be seen in the corners. Remove the thumb screws and separate the upper and lower components. The lower component has an electrode capillary on each side. It also has two cones to accept the retinal samples. The sample is placed cup side down at the center of the cone on top of the nitrocellulose filter. The upper component also has an electrode capillary on each side. These additional capillaries that are seen running from end to end will carry the perfusion solution during the experiment. When you receive your sample holder, the filter material will already be attached to the two cones of the lower component. Over time, the filters become worn with use and need to be replaced. When this occurs, use a sharp razor blade to scrape off the old filter material. Once the filter material has been removed, use some alcohol to thoroughly clean the top of the two cones. After cleaning, use a 25 gauge needle to apply a very thin bead of glue around the perimeter of the cone. Work from a small pool and use the needle to transfer just tiny amounts. It is important that the bead of glue be continuous to prevent electrolyte solution from leaking out around the edge of the filter. Take special care to avoid getting glue in the hole in the center, as this will block transmission of the signal to the electrode. If glue gets into the center, flush it immediately with an alcohol-filled syringe. The best practice is to flush from the threaded end of the capillary and start over. You can use some alcohol to clean the sides of the cone if necessary. Just be careful not to interrupt your bead of glue. Attach the filter material before the glue sets and position it in the center. Apply some light pressure around the edges to adhere the filter to the glue. After the two filters have been attached, the sample holder should appear like this. Make sure the glue is allowed to dry completely before using the sample holder. The following steps will describe how to fill the electrode capillaries with the electrolyte solution. To do this, we'll use the 25 gauge needle and syringe that came with the sample holder. The primary objective is to eliminate air bubbles from the electrode capillaries. Fully insert the needle into the electrode capillary. Then fill the capillary in recess while slowly withdrawing the needle. Make sure the recess is completely filled with solution, then carefully screw in the electrode to avoid any cross-threading. The electrode should be screwed in tightly enough that its O-ring becomes depressed. This is important to prevent air bubbles from entering the system during the experiment. As the electrode is screwed in, you will observe electrolyte solution exiting from the filter at the top of the cone. The upper portion will be flushed in much the same way as the lower portion. But first, we should attach the 4 barbs from your kit into each end of the perfusion channels. To simplify the flushing process, we attach a short piece of Tygon tubing to the barbs on one side of the upper component. The capillary is filled in much the same way as it was for the lower component. Use a gloved finger to block the center hole while filling the electrode capillary. Unblock the opening momentarily to allow air to escape. Making sure that the electrode recess is completely filled, carefully screw in the electrode. Again, the electrode should be tightened sufficiently to depress the O-ring. This will prevent air from leaking into the system during the experiment. Swap the short piece of tubing to the other side of the upper component, then install the electrode as described previously. Now we can reassemble the sample holder. Note that there is only one way to connect the upper and lower portion to each other. It is very important that the two large O-rings at the center be depressed. This will prevent leakage and crosstalk during the experiment. Alternately tighten the thumb screws so that the depression of the O-rings is uniform. Now that the sample holder is fully assembled, we can give it a quick flush to remove any residual air in the lines. Adjust the multimeter setting to 200K ohms, then measure the resistance across two electrodes on the same channel. The value should be below 100,000 ohms, although the ideal is below 20,000 ohms. Values out of range indicate air bubbles in the electrode capillaries. If air in the electrode capillary is suspected, the electrode should be removed, the electrode capillary flushed, and the electrode reinstalled as previously described. Resistance should be brought to acceptable levels before proceeding. The sample holder can now be introduced to the system as described in our video, setting up the OcuScience Ex Vivo ERG adapter. We suggest running a brief protocol to test for the presence of environmental noise. If the noise is at acceptable levels, the sample holder is now ready to accept the retinal samples. Engage the slide clamps at both ends of the drain lines, then stop the flow of perfusion. Now we can take the sample holder out of the circuit. Use two spare barb fittings from your kit to connect the drain lines to the flow control assembly. After the retina has been mounted to the sample holder, it can be reintroduced to the circuit. With the sample holder reintroduced, the user can now proceed with the steps as described in the system setup video. A link to that setup video will be provided, as well as a link to a related video from the Journal of Visualized Experiments. Feel free to contact us if you have any questions about the OcuScience Ex Vivo ERG recording system.